Procedural to object-oriented programming. The topics in this lecture will cover algorithms and procedural programming, issues with procedural programming, object-oriented defined, object-oriented concepts, procedural versus object-oriented, and then there will be a concrete comparison of the hierarchies between procedural and object-oriented programming, and then another concrete comparison for procedural and object-oriented programming code samples. Algorithms and procedural programming. Algorithms focus on procedures, functions, and carry out actions. Data is passed into functions as arguments. This data is stored in variables. The functions actions are algorithms that process data structures. And usually in a procedural programming program, functions are grouped together with higher level functions, thus creating a top-bottom approach. At times, developers will also use bottom-up approaches, meaning they create functions and then they group them into modules, but before grouping them into modules, they group them into functions and then into modules. So that is where that word comes from, top-bottom approach, or bottom-up, sorry. So issues with procedural programming. As programs grow in size, functions are grouped in modules. The program becomes difficult to maintain, and it also becomes difficult to test. Since procedural is based on functions, an industry-wide program can have a lot of functions, many functions. Thus, if a change needs to happen, then the program is difficult to test and extend or change. Making one change to a function may cause problems or cascade issues into other parts of the program. So the regression testing meaning like testing that the program still works properly after a change is made, it takes up a lot of time. So that's one of the main reasons procedural programming has issues. Now, they're prone to error mainly because functions are developed from a programmer's view. Like my perception of a payroll program may not be the same as a student's, right? So they're prone to error, and thus this will introduce logic errors. Object-oriented defined. In a non-technical world, an object is a tangible thing all around us. Since we were kids, we see objects and we deal with objects, and we've just never related objects to a technical context. So these objects are synonymous to nouns. In programming context, objects are models of things. These things can perform actions, and they can also have actions performed on them. For example, a grade book, an object, has student grades posted to it, an action. In software development, object-oriented means functionally directed toward modeling objects. Model complex systems by describing a collection of objects that interact with each other. Thus, we will be creating models of domain problems and solving them with object-oriented methods. object-oriented concepts. Abstraction, these are objects that represent real objects as models. They deal with the appropriate level of detail. This concept is abstract, but we'll have some concrete examples to understand this. They focus on the outside view of an object. They separate an object's behavior from its implementation. Abstraction focuses on the observable behavior of an object. And finally, abstraction is a process of encapsulating information with the appropriate level of detail. Now, we're talking about abstraction, and this slide doesn't bring a lot to the forefront for us. However, in the next slides, we will make this slide make some sense. So, for example, abstraction, an example. So, as I said, we focus on the actions that are performed on an object. In this case, we have a bank account, and a bank account object can be opened, it can be closed, money can be deposited and withdrawn. So the details of the actions performed on a bank account object are hidden from another object's view. Other objects can open, close, deposit, and withdraw funds by interacting with the bank account object, but they don't know how open, close, deposit, and withdraw were implemented. All that object cares is that when they open a bank account, it opens. Likewise, when it closes, they deposit money, that bank account grows, and when they withdraw money, if there's funds, then those the balance is decreased. So that was an example of an abstraction. Object-oriented concepts continued. So another concept is encapsulation, which is the process of hiding the implementation of an object by combining data and code into a single object. Only the object directly accesses its data. Only the object makes changes to its data. Encapsulation hides all the secrets of an object that do not need to be seen from the exterior. That includes structure and the implementation. So again, very abstract definition. However, we have a concrete example to make sense of this slide. So encapsulation, we have the bank account example. So maybe variables or member variables that belong to this bank account object are balance, interest, and a list of transactions that have occurred to that bank account. So other objects can only view and modify data the bank account object allows. So bank account allows other objects to modify the balance, however, via the deposit and the withdraw methods, right? And it probably keeps a transaction array or vector and will expose it when there's a bank account statement printed or when a customer wants to see their transactions, right? So there would be another object that would use bank account object to get a balance or list transactions. Now, excuse me, procedural versus object-oriented programming. So the first half of the semester, we've focused exclusively on procedural programming. We've skipped everything, any section that has to do with object-oriented programming. And I've also told students that object-oriented and procedural programming are not the same. Procedural, we think sequentially, and in object-oriented programming, we have to think in objects. We have to think of models of domains, and we will explain this further. So algorithms, they encapsulate actions in a series of steps, while object-oriented programming encapsulates data and actions. Modifying a step in procedural program will cascade issues to other steps. However, in object-oriented programming, modifying an object's data and actions occur distinctly from other objects. And if programmed correctly, and we will learn how to program objects correctly, then changes will not cascade like they do in procedural programming. Furthermore, algorithms are broken down to a developer's perspective, meaning, like I said earlier, like my view of a payroll program may be different from 5 students' view. However, in object-oriented programming, the model relies on a domain expert who knows domain objects. So this would be maybe somebody who knows the payroll system. So then they would describe the objects for us and we would model those objects. Now, algorithm hierarchy, misspell here, let me fix it. Sorry. Are top-down structures, while object-oriented programming and classes hierarchy depends on how objects are related to each other. Again, very difficult to imagine, but we will see some images to clear this up. So algorithms, as you can see, are functions, right? So for example, this is a program that deals with files, and as you can see, like update file, and then there's a function get master area, get formatted update, match update, and what have you, right? So it's a list of actions that can be applied to a file in a file program. So, and those actions are more than likely in functions. Now let's look at the same program but from an object-oriented perspective. So we will see the model, and as you can see, there's a lot less objects, or not objects, a lot less clutter, right? So we have a master file, we have a master record, and we have a checksum, we have update to cart and file of updates. And as you can see, the arrows describe what actions can be performed. So again, much, so let's see, so this is algorithms, as you can see. So from this picture, you can begin to understand why algorithms, functions, procedure programming, as the program grows to an industry wide or level program, this hierarchy is going to grow exponentially. However, in objects, it'll still grow. However, a human or a programmer will have a better chance of understanding it, and it'll take less effort to understand it. So this diagram, please, it's important, don't forget it. So let's have an example of code. For example, the binary to decimal and decimal to binary. So this is the main program. So we have two functions, get decimal, get binary, and we send them arguments and they give us a result, right? So here we call the program. And the next slide, we will see the code, right? So get decimal is a function and get binary is also a function. So that's how we would code a binary calculator, maybe, right? So how would we code this in an object-oriented way? So we would create an object, right? So in this case, we create a class byte that represents 8 bits, right? And we won't go too much into the code, right? So let's for now just say we created a byte object, and all these methods make this byte class work. For example, we have, I'll just talk about the methods, right? So we have a get decimal and a get binary, and then when we can even set binary, set decimal, but for now that does not matter. So I'll go to the next slide. Don't worry too much about the code. Just for now, just say, okay, this class byte. So in C++ we use classes to model objects, right? For now, let's just leave it at that. We'll talk more about this in the lecture. And then we create a calculator object, binary calculator, and again the class to create a binary calculator, and this calculator can calculate, get decimal or set decimal, right? And finally we have the methods, right? So we have a set decimal and set binary, and as you can see, this byte variable exists in this scope, so the class's scope. So byte exists in the class's scope. So when we call calculate, we're gonna check if this byte has a -1 value. If it does, then we want to set binary. Otherwise, we want to set decimal. And I'll talk about this example in class a lot more than I am now. And then we have get byte, right? So now we saw the byte object, we saw the binary calculator. So now let's see how we would use it from a main function. So we saw this code. So as you can see, in main we create an object byte, right? So we send it a binary value of 1001 0101, and then we create a calculator object here, and we say we want to use this byte object, and then we call calculator.calculate so that it can get decimal, and then we display the decimal value, and then we turn around and we create another byte object, and we send it the value 149, which is 1001 0101, and then we call calculate, and then we display get binary. So that's how we would create this binary conversion program in an object-oriented way. And finally, the last slide, the references. So I got this information from 3 books, right from the textbook in the class. I thought that some of it needed a little bit more explanation, so I went out and looked at very popular object oriented analysis and design book by Butch. This was from 2007, and then I also wanted to get an explanation for you all on how students or how developers need to think when they migrate their thinking from procedural programming to object-oriented programming. And this was this book, Rationale for Object-Oriented Development. And we will be I'll be getting some more information from this book from now on, because I think it's important that students understand that we cannot do object-oriented programming if our mindset is thinking in a procedural programming manner. And that was the end of this slide.